Imagine our world ravaged by hurricane-force winds, with temperatures swinging from scorching heat to freezing cold. The day lasts just 6 hours, in a world where only primitive life forms will ever evolve. This could be planet Earth, if it had no moon. The moon is an 81 million billion ton lump of rock and dust, almost 3,500 kilometers in diameter, orbiting 400,000 kilometers above our heads. It's the second brightest object in our skies, with temperatures ranging from 120 degrees Celsius to less than minus 230 degrees. Its gravity is a sixth of that of the Earth. It has mountains that soar to almost 5,000 meters, and millions of craters litter the dust-dry surface where no liquid water has ever been found. This is not a hospitable place. And yet we often associate the moon with romance and mystery. The man in the moon enraptures people all over the world and feeds our hunger for supernatural myths and legends. We are far from alone in having a moon. There are at least 135 other moons orbiting the planets in our solar system. Saturn has the most with 46. But there are at least 10 mysterious bodies orbiting our planet. 5 are asteroids temporarily caught by the Earth's gravitational field, and 4 are probably remnants of the Apollo 12 rocket. The 10th and largest is our moon. Since long before the birth of humankind, the moon has been the Earth's constant companion. But until relatively recently, we've known little about its true nature, or even how it was created. Scientists explored several competing theories. One suggested that the moon was an asteroid or planet trapped by the Earth's gravity. Another ascribed its creation to a giant impact on Earth, which ejected masses of material that formed the moon. Clues as to which theory was more likely to be correct came when man first landed on the moon and began to unlock the secrets of creation that were buried within its lunar rocks.
5, 4, 3, 2, 1, 0. Liftoff.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Between 1969 and 1972, 6 missions blasted off to the moon.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal.
Only 12 humans have ever walked on the moon. But these astronauts did more than just rewrite history. They also returned with samples of lunar rock. These moon rocks were amazingly similar to Earth rocks, but they contained far less iron, and this seemingly small difference offered a huge clue as to how the moon was created. It showed that the moon started with a bang. Four and a half billion years ago, the moon did not yet exist. The inner solar system had about twice as many planets as the 4 that exist today. But many of them were on a crash course to destruction. Among them was a planet about half the size of Earth, since named Theia, who in Greek mythology was the goddess mother of the moon. And it was on a collision course with our planet. Theia rushed closer and closer to Earth. The approaching planet would have been a terrifying sight. Astrophysicist Jeff Taylor has studied the moon's fiery birth and describes the view from Earth as Theia raced towards it.
It might have started looking like a star, or a pretty big star, but then as it got closer and closer, this thing would get bigger and bigger and bigger and bigger and bigger until it just filled the sky moments before the big impact. And then everything would be gone for you as a witness, and there would be a giant flash because everything would be white hot. And if you were standing, or a friend of yours, on the other side of the Earth, they would see the flash in the atmosphere and feel gigantic earthquakes passing through the Earth.
Theia was 6,500 kilometers in diameter. To put that into context, the meteorite thought to have wiped out the dinosaurs was about 10 kilometers across. And Theia was traveling at 40,000 kilometers per hour.
This is an object that is the size of Mars, which is about half of the Earth's diameter. So it's a gigantic event of unimaginable power.
As the planets got closer, their immense gravitational fields ripped each other's outer layers to pieces. Then they catastrophically collided. The impact was equivalent to billions of megaton bombs. It sheared off continent-sized sections of the Earth's crust and blasted surface rocks out into space. These surface rocks contained only a small amount of iron. The atmosphere around the molten planet was filled with rock vapor. Earth's gravity pulled back most of the debris, but some was catapulted into space, although it couldn't escape completely. Instead, it was trapped by the Earth's gravity, forming a ring of red-hot dust and rock around the planet. In a process called accretion, the circling dust and rocks collided and fused with other fragments to create larger blocks.
We can represent this process by olive oil and water. The water here represents the space around the Earth, and the olive oil is the debris thrown around the Earth by this giant impact. And each little droplet that we pour in here represents a given chunk of matter thrown up, blasted off the Earth. We're going to stir this around, indicating the way the debris is being moved around the Earth.
When Taylor stopped stirring, the drops bump into each other and clump together as bigger droplets.
And that process of small things bumping into each other, becoming larger, is called accretion. And that's how the moon formed around the Earth. That's how the Earth formed around the sun.
As the debris clumped together, its combined gravity became strong enough to attract even more debris. This chain reaction didn't stop until the billions of fragments of vaporized rock had gathered into one red-hot ball of matter. In less than 100 years, this cooled, becoming a solid lump of rock 1/50th the volume of Earth. It became the Moon. When the Moon formed, it was just 27,000 kilometers away. But it didn't stay as close as that. Its violent birth set it spinning away from us on a journey that would last for 10 billion years. Absolute proof that the Moon is moving away came in 1969, when astronauts left a 45-centimeter reflective plate on the Moon's surface. By bouncing lasers off this plate, scientists can pinpoint the Moon's distance from Earth to within a few centimeters. Such calculations reveal that the Moon is moving away from the Earth at a rate of about 4 centimeters per year. So why is the Moon on the move? In the 1990s, Supercomputers gave scientists a more accurate picture of what happened 4.5 billion years ago. Computer models of the impact revealed that the collision of Theia and Earth was a glancing blow that imparted a rotational force to the Earth. This rotation is what gives Earth days and nights. But the huge power of the collision set the Earth spinning far faster than the Moon, which was orbiting around it. In those early days, Earth spun once every 6 hours, 4 times faster than today, whereas the Moon took 20 days to complete one orbit. So the Moon was orbiting more slowly than the Earth was spinning. However, the early Moon was 15 times closer than it is today, and the effect of its gravity was so strong that it pulled up a bulge on the Earth's surface directly below it. This bulge moved like a tide across the surface, with its own gravity tugging on the Moon. Because the Earth was spinning faster than its satellite, the bulge was always ahead of the Moon, so it constantly pulled the Moon forwards, causing it to accelerate. Any object that travels in a circular motion will move outwards as it accelerates, much like a hammer being thrown in the Olympics. So as the Moon accelerated in its orbit, it began to spiral away from Earth. This journey would continue for billions of years. At the time of its birth, the Moon orbited Earth 15 times closer than today. But this close proximity put the Moon in great jeopardy. It faced bombardment by thousands of asteroids that would eventually destroy 80% of its surface. $4 billion years ago, the time the scientists call 4 giga-years ago, or 4 GYA, the Moon was orbiting 140,000 kilometers away, still 3 times closer to Earth than it is today. From our planet, the Moon dwarfed everything in the sky. During this early period of its life, the Moon had its most profound effects on Earth. The massive collision that created the Moon was so powerful that it knocked the Earth off balance onto an axis of 23.5 degrees. It's this tilt that gives us our spring, summer, autumn, and winter. If we spun on a vertical axis, like the planet Mercury, seasons wouldn't exist. Everywhere would receive 12 hours of light and 12 hours of darkness. The poles would be entombed in an eternal freezing twilight, while the equator would bake in endless heat. But the Moon did more than merely produce this tilt. It also maintains it. The strong gravitational pull of our Moon acts as a global gyroscope, stabilizing the Earth's axis. Astrobiologist Lynn Rothschild explains how this works.
The reason we have this obliquity that holds steady is because the Moon helps to stabilize the obliquity of the Earth. If we had no Moon, we would end up with what the astronomers call a chaotic obliquity. We'd have quite a big shift and fairly low timescales.
Without our global stabilizer, our axis could vary between 0 and 90 degrees. This would alter the distribution of sunlight across the surface of the planet, devastating our finely balanced weather systems. Climate patterns would go berserk. The tropics could find themselves frozen under ice, and Antarctica would be transformed into a vast desert. But luckily, the Moon saves us from such disasters and allows life to exist.
It turns out that it may have had a really profound influence on how life has originated and evolved on the Earth. In fact, you might almost be able to argue that we wouldn't be here today filming this if the moon weren't up in the sky.
Not all the planets in our solar system are so lucky. Mars has 2 moons, but they're too small to stabilize its tilt. And as a result, the red planet rolls much more than Earth. Some scientists believe that this is one of the reasons there's no life there now. When we look at our moon today, the first things we tend to notice are the craters. To an astrophysicist like David Kring, these indicate a distant and violent past.
You can look up from your own backyard and see impact craters on the lunar surface. There are over 300,000 craters, half a mile to over 500 miles in diameter on the lunar surface.
Most of these craters came from meteorites hitting the moon. The largest crater we can see from our planet is the Imbrium Basin, which is 1,100 kilometers across. Moon craters come in various sizes, but almost all were created at about the same time. Around 4 billion years ago, a chance alignment of the gas giants Jupiter and Saturn changed the shapes of their orbits. This created a slingshot effect, hurling asteroids towards the inner solar system, straight at Earth and its young moon. For millions of years, asteroids bombarded the entire inner solar system.
Some of these impact events would have produced impact craters the size of continents or larger. These type of impact events have the capacity to obliterate any oceans on the surface of the planet and superheat the atmospheres. Life as we know it could not persist on the surface of the Earth.
This period of intense bombardment is called the lunar cataclysm, and the Earth's gravity made it worse, pulling meteorites and asteroids directly towards it. On its own, the tiny moon might have escaped with less damage, but it was too close to the Earth. So asteroids heading for impact with Earth hit the moon instead. The moon became the first victim of collateral damage. Most of the craters on the moon formed during the lunar cataclysm. 80% of the lunar surface was destroyed. Molten basalt oozed from fissures and filled impact craters, creating seas of lava. Over millions of years, these cooled, solidified, and turned into maria, or seas, like the Sea of Tranquility. It's the pattern of dark basalt rock that creates the face of the man in the moon as we know it today. David Kring demonstrates exactly what happens to the surface of the moon if a meteorite strikes. He releases a 2.5 kilogram rock from 15 meters above a sand pit. On impact, sand is fired upwards into the air. During the lunar cataclysm, some impacts were so big that material which fired upwards never returned to the moon's surface. Instead, it was propelled into space, where it was trapped by the gravity of the Earth, still only 140,000 kilometers away. Some of these rocks hurtled towards our planet.
You actually would have seen a huge plume of debris rise up off the lunar surface. This cloud, in fact, would have enveloped the entire lunar surface, and out of that cloud there would have been fragments of rock that pelted the Earth. They would have streamed through the atmosphere as intense fireballs to land rocky components on the Earth's surface.
These lunar meteorites are incredibly rare. This is part of one of only 30 known lunar meteorites ever found.
So this is a sample that fell in Africa. Analyses of samples like this tell us that there was a cataclysmic spike in the number of impact events that affected the moon 3.9 to 4 billion years ago.
Lunar meteorites contain a record of the geological history of the inner solar system as it was around 4 billion years ago. These rocks are older than the oldest rocks on Earth. The existence of lunar meteorites on Earth caused experts to wonder. If rocks could be catapulted from the moon to Earth, could rocks from the Earth also reach the moon? And if such Earth meteorites could be found, might they hold fascinating clues as to what was happening on this planet billions of years ago? To blast anything free from Earth's strong gravity requires immense force, far more power than it takes to launch a lunar meteorite off the surface of the moon. For example, a space shuttle uses 15 million horsepower to escape from Earth's gravity. A lunar module needs just 6,300 horsepower to lift off from the moon. But just how big an impact would it take to blast debris off the Earth? Award-winning astrophysicist Guillermo Gonzalez from Iowa State University has worked out the answer to this question.
The crater in northern Arizona, Meteor Crater, even that, which is really big when you go right up to it, wasn't large enough to catapult any significant amount of material beyond Earth's atmosphere. But when you're talking about, say, the crater that killed the dinosaurs in Mexico, now that one was probably big enough to start launching some at least small amount of material beyond the Earth and have some of it land on the moon.
Impacts on Earth during the lunar cataclysm were far bigger than the dinosaur extinction event. They had so much power that they punched holes in the Earth's atmosphere. Rocks and debris thrown skywards escapes through these holes, and once in space, some of the debris was vacuumed up by the moon, orbiting just 140,000 kilometers away.
And it eventually makes its way to the moon, where it lands. And then when it lands on the moon, of course, it could be further broken up into smaller pieces depending on how fast it hits the surface.
Since landing on the lunar surface, they've remained perfectly preserved in the vacuum of space.
The early Earth, unfortunately, erased its early history, but it left a record of it, at least a partial record of itself, on the moon. And if we can find some fossils or at least remnants of early life in these Earth rocks on the moon, that can help us answer these difficult questions about the origin of life.
Gonzalez believes that close to 20,000 kilograms of Earth rock could be spread over every 100 square kilometers of the moon's surface.
It's the only place in the solar system that we can go to learn about the origin of life, because once the Earth rocks get to the moon, they're preserved there in a pristine form. There's no water cycle on the moon, there's no more active geology, and they get buried relatively quickly from the material from other impact on the moon. And so they're preserved from the solar wind and other things as well.
So far, no Earth rocks have been found on the moon. Gonzalez will have to wait until the next moon mission and hope that these priceless rocks may then be discovered. The first half-billion years of the moon's journey from Earth was a violent one. Over the next billion years, the moon continued its escape from Earth and out into space. And its passage changed the face of our planet beyond all recognition. The power of its gravity created tides hundreds of meters high, which stirred up the oceans of the Earth. And this created the conditions for complex chemical compounds to form. The moon was aiding the creation of life on Earth. "3 billion years ago, the moon was still escaping from the Earth and orbiting around 320,000 kilometers away. The effect of its gravity was now weaker, but it still had the power to radically change our planet. The Earth had water and oceans, and the moon was stirring things up. It was too far away to have a dramatic effect on the rocks of the Earth, but the moon did affect the oceans. As the moon passed overhead, its gravity created tides in the water. But these weren't like the tides of today. They were hundreds of meters high. Astronomer Neil Commins has studied how the early moon affected the tides.
When the moon first formed, the tides were something like 1,000 times higher than they are today. They would have gone inland as a wall of water, 10,000 feet high as a huge mountain. They probably would have covered hundreds of miles. And then they would come back, scouring the land, taking debris from the surface of the Earth into the oceans.
The material sucked into the seas contained minerals and nutrients, and the tides created by the moon churned these into the most crucial cocktail in the history of the Earth, the primordial soup. Different combinations of minerals were bound together and torn apart, and it was in this violent melting pot that the right combination of minerals was forged into life. Cummins believes that the spark of life might never have occurred had the moon not churned up the primordial soup.
The moon created those tremendously high tides back when it first formed that allowed the oceans to fill with minerals, that allowed life to evolve, that allowed us to be here.
The tides may even have helped the first DNA to evolve. Some scientists believe that the changes in chemical concentrations when the tides went in and out caused the DNA to split and replicate. And the enormous moon-induced tides had a further vital role to play in the history of the Earth. They helped the whole atmosphere of the planet to calm down and become a more hospitable place in which more complex life could evolve. 3 billion years ago, the Earth was a very different place. The impact that had created the moon also set the Earth spinning faster. It spun so much faster than it does now that a day lasted just 6 hours. And this high-speed spin had devastating effects right around the Earth. The rotation of our planet is one of the most influential factors determining global climate. The spin of the planet creates winds and vortices in the atmosphere, and the faster the spin, the faster and more violent the winds. Billions of years ago, when our planet rotated 4 times faster, the atmosphere whipped over the land.
When a hurricane occurs today, 100-mile-an-hour winds, trees are blown over, houses lose their roofs, tremendous amount of flooding. But in a day or two, it's gone. Things settle back to normal, people get on with their lives. Imagine if we lived on a world in which those kinds of winds were continuous.
This was the climate of our fast-spinning early Earth. A place with constant hurricane-force winds and giant 3,000-meter tides. It was far too hostile a climate for life to evolve into more complex forms. But the devastating tides created by the moon began to pacify this hellish climate. The tides affected the speed of rotation of our planet, eventually lengthening a day from 6 to 24 hours. As the Earth's rotation slowed, the atmosphere ceased to whip around the globe. Hurricane-strength winds were no longer the norm, and more complex life forms began to evolve in the relative peace and calm of our planet.
I really think that we owe the moon our existence today. Without it, the world would have evolved differently, and as a result, we would have evolved differently. We would not be the creatures we are.
The power of the nearby moon has dramatically reshaped our planet. Over the last 3 billion years, the moon has continued its journey out into space. Its influence has waned, but it hasn't disappeared. Some scientists believe it causes earthquakes and volcanic eruptions, while many laymen still believe that the full moon can affect human behavior in some bizarre and inexplicable ways. Today, the moon orbits Earth 400,000 kilometers away, 15 times further from Earth than when it first formed. It now appears as a distant and mystical object in the sky, and its gravitational pull is far weaker than it used to be. It's now so small that it exerts the same upward pull as a pea held about half a meter above your head. But some people believe that even this weak power can affect human behavior. The moon's 29-day orbit around the Earth is called the lunar cycle. And during the lunar cycle, the appearance of the moon changes because it's constantly moving relative to the sun and Earth. The full moon has long been associated with mystery, aggression, and horror. Studies show that the behavior of some animals does change during the lunar cycle. Some creatures' whole breeding cycles are dictated by the moon. Scientists have also investigated the link between predation and the full moon. Researchers think that the increased moonlight helps some nocturnal hunters track and kill their prey, although the idea that wolves howl more often during a full moon is nothing more than a myth. So some mammals do become more active at full moon. Could this aggressive lunar trait extend to humans? Here in San Francisco, officers Healy and Mahoney of the San Francisco Police Department gear up for another night patrolling the town. They've been policing the Tenderloin district for the last 10 years. But this is no ordinary night. It's a full moon. And on full moon nights, things here definitely feel different.
I think some of the clientele we deal with, they think it's a full moon every day, I think, but there's a noticeable difference. You could pretty much ask anybody who works in, service jobs like police, fire, paramedics, hospital workers. They'll all tell you that during the times of the full moon, business just goes up.
But is there any scientific evidence that human behavior can be affected by the moon? In 1976, the American Journal of Psychology studied 34,318 crimes and found they occurred more frequently at full moon. And a year later, researchers studying 18,495 psychiatric patients found that hospital admissions peaked during a new moon. However, a series of more recent studies has revealed no link between human behavior and the lunar cycle. And yet many people still believe in the power of the full moon, possibly because of horror movies and folklore. For generations, we've been led to believe that murder, death, and even mythical creatures such as werewolves are linked to the full moon. So it's not surprising that over time, we might start to believe this is true. The effect of the moon on humans may be minimal, but some scientists believe that its gravity still exerts a major influence on the Earth. It's not just the moon's appearance that alters with the lunar cycle. Its gravitational pull varies as well. At new moon, when the sun and the moon are aligned, their combined gravity tugs even more than usual on the Earth. As the moon makes its way around the Earth, it pulls us in different directions. And when there's a full moon, the sun and moon pull in opposite directions in a kind of astronomical tug-of-war. For most of the lunar cycle, there's no danger to the Earth. But when the sun and moon are aligned, their combined gravity creates maximum stress on the Earth's crust. And some scientists believe this can trigger devastating natural phenomena. Volcanologists Donna and Steve O'Meara use this cycle to help predict eruptions. While other scientists check sulfur levels and study seismographic data to make their predictions, Steve and Donna plot the position of the moon, which they believe has the power to trigger eruptions at certain points in its orbit. The O'Mearas believe that in the complicated cycle of tugs and pulls from the sun and moon, increased stress can distort molten rock within the Earth. At the crust's most unstable points, where volcanoes form, the pressure can sometimes become too great and trigger an eruption. The O'Meara's eureka moment came in 1996 on an expedition to an erupting volcano called Arenal in Costa Rica.
Well, the coolest thing is that all volcanoes are different. They're just like people. They have different personalities. I mean, obviously there's different types of scientific volcanoes. This is a shield volcano, which has very fluid eruptions. Stratovolcanoes have huge eruptions. And volcanoes, we've actually gotten to know some, and like Arenal volcano we call the brat, because it's just always.
During their 2-week expedition, Arenal erupted 15 times, and they realized that the biggest eruptions occurred when the moon was directly overhead. By tracking the moon's position over Arenal, the O'Mearas have predicted eruptions with an accuracy of 80%, a feat unparalleled in the world of volcanology.
In one of them, we in fact woke the villagers and told them that, get prepared, there's going to be an eruption at 12:30, and bang, 12:30, the thing erupted right on schedule.
Since 1996, the O'Mearas claim to have used the moon to correctly predict eruptions all over the world.
Either I have to be the luckiest person on Earth, or the moon is affecting volcanic eruptions.
But the moon may trigger natural disasters on an even bigger scale than volcanoes. One scientist now believes that the moon may have caused 2 of the worst natural disasters in recent years. The October 2005 earthquake in Pakistan and the 2004 Asian tsunami. Today, the moon is still on its journey, edging away from Earth at a rate of 4 centimeters per year. But even from 400,000 kilometers out in space, its gravitational pull can still affect our planet. It's been suggested that the moon can trigger volcanoes, but geologist James Birkeland thinks it plays a far more destructive role. He believes that the moon triggers earthquakes, quakes that can kill many thousands of people. In 1994, Birkeland traveled to Peru to witness that rare moment when the sun and moon perfectly line up to create a solar eclipse.
In Peru, a large earthquake is called a terremoto, and we saw this great eclipse, and the Peruvian guide said, "I am so glad you were able to see our eclipse. We in Peru have a tradition. We watch the eclipse and then we wait for the earthquake."
The ancient Peruvian belief that solar eclipses are involved in triggering earthquakes supports something that Birkeland has been investigating for the past 3 decades.
They have known what I've known for 50 years almost, that the lining up of the sun, moon, and earth often can trigger quakes.
The Earth's crust is made up of 7 tectonic plates that bump and grind against each other, creating a series of fault lines. At these points, the opposing plates scrape against each other, sometimes slipping or pushing upwards. This sudden movement causes earthquakes. Birkeland thinks that the relative position of the moon and sun above these fault lines is critical in the triggering of quakes.
When I saw the ocean tides due to the passage of the moon, then it occurred to me that perhaps it might loosen up the fault lines and sort of lubricate the faults and make them easier to slip.
He monitors the location of the sun and the moon during the lunar cycle as they pass over these danger zones. He also factors in how close the moon is to the Earth, since the moon's orbit isn't a perfect circle, but elliptical. The nearest point of the moon's orbit is called perigee, and its furthest is called apogee. At perigee, the moon's pull on the Earth is 20% stronger than at apogee.
Now the Earth is here, and the moon travels around the Earth in a very elliptical orbit. It's exaggerated here, but when it's at its near point, we call it perigee, it's only about 221,000 miles away from the Earth. When the moon is close, its effect on our tides is far greater than it is over here at the far point, at apogee, 253,000 miles away, just 2 weeks later.
By combining all this information, Birkeland calculates how much pressure the moon is putting on certain fault lines around the world as it passes overhead. And he suggests that a new moon at perigee can actually cause unstable fault lines to slip. His technique has allowed him to predict several earthquakes during the past decade. But his theories are controversial. In 1989, Birkeland was suspended from his job as county geologist for Santa Clara, California, until he promised to stop making predictions that would cause mass panic. Other scientists doubt that there's a link between the moon and earthquakes, but Birkeland claims that some of his predictions have proved to be correct. In October 1989, Birkeland warned the city of San Francisco that a big quake was about to strike. A few days after his alert, during the World Series, Birkeland's tragic prediction came true.
When the World Series quake hit, I was on the 7th floor of the county building. When, boom, the P wave hit. And for 2 seconds, I was elated. I got my quake! And then I didn't want any part of it because I was being rocked back and forth. I held onto the counter. It was frightening.
The magnitude 6.9 quake caused $6 billion worth of damage and claimed 63 lives. It was the biggest earthquake to hit San Francisco in 80 years.
Police with information.
Predicting a 6.5 to 7 from the Bay Area when we hadn't had such a quake since the 1906 quake is a pretty good call.
Birkeland's ideas are radical, and the exact nature of the moon's influence on earthquakes is not well understood. However, in 2004, Birkeland predicted that a huge earthquake would occur around the time of the full moon, just after Christmas. The earthquake that triggered the Indian Ocean tsunami duly occurred on the 26th of December 2004 at a full moon. In 2005, Birkeland predicted a magnitude 7 earthquake, and within weeks of his prediction, a 7.6 quake hit Pakistan, just after a solar eclipse over the country. Could these events demonstrate the moon's continued influence on our planet, even though that influence is waning? Today, the moon and the sun appear exactly the same size in the sky, meaning that the moon covers the sun during a solar eclipse. But in the distant future, 500 million years from now, the moon will be so far from the Earth that eclipses will be a thing of the past. And in less than 2 billion years hence, with the moon no longer holding the Earth on its axis, the planet will rock back and forth. The weather will become wild and threaten the existence of life on Earth. Billions of years into the future, when the moon has reached the end of its journey away from the Earth, its orbit will stabilize. And in 5 billion years, when the sun expands as it nears the end of its existence, the Earth and the moon, so inextricably linked in life, will be together in death, engulfed side by side by the awesome heat of our dying sun.